Okay, so today we're going to continue talking about exponents, and everything we've done so far, the exponents have always been a positive number. Exponents can be any kind of numbers. So mostly in grade 9, exponents are positive numbers. That's what I'm required to teach you and stuff like that. Right? And you go off to grade 10, you start working with negative exponents, you start working with fraction exponents, right? Exponent's just a number, right? So today we're going to look at what does a negative exponent mean, right? How does that work out? So let's look at this first example. Here, if I ask you to write this as a single power, we're dividing, the base stays the same. What do we do with exponent? Minus. So you go 7 minus 4, we write down 3. Okay, and we're going to go over here. We are dividing again. The base stays the same. What do I write for the exponent this time?
3.
Well, it's different, right? The first one's 7 minus 4. Right? So now we have to go 4 minus 3. And I heard no on the back, right?
Yeah.
It'll be negative 3. So what does a negative exponent mean? Remember, an exponent just meant repeated multiplication. So this one's easy. That means 6 times 6 times 6. Right? We repeat the multiplication 3 times over. How does that look like with a negative exponent? What does that mean? To answer that question, we're going to write this as a repeated multiplication. So remember, a division can be set up as a fraction. So on the first one, on the left number is the numerator. We would have 6 7s there. 1, 2, 3, 4, 5, 6, 7. And this is going back to day 1. In the second number, we would have 4 6s. That's what that means on the bottom. Right? And we talked about canceling, right? And a factor on the top will cancel a factor on the bottom. A 6 on the top will cancel a 6 on the bottom. So we have, like, this 6 will cancel this 6. And we talked about this 6 canceling this 6. And this, running out of colors here, let's go gray. This 6 will cancel this 6. And purple. And what we have left over is our answer. Okay? Now I'm going to do the same thing for the other question. How does that look like? So bear with me. So this time we have 4 5s on the top. And we have 5 7s on the bottom. 3, 4, 5, 6, 7. And we do the same thing. To come to the answer, we cancel out the 5s. A 5 on the top will cancel a 5 on the bottom. And I just go through reducing this as much as I can. And what I'm left with is here. Still 3 5s, but what's the difference in the location of the 5s? Noah? It's on the bottom. So if I simplify this, we have 3 5s on the bottom. On the bottom, on the top, everything canceled out, so just a 1. Okay? So a negative exponent sort of implies that we have a repeated multiplication in the denominator. Okay? Whereas a positive one, we have the repeated multiplication in the numerator. That's all the difference is. Now, the thing is with math, there's a convention, right? There's nothing wrong with negative exponents, right? The calculations remain exactly the same. But somebody has decided that, hey, when we represent numbers, we prefer to write them as positive exponents. So if you do your calculation and you end up with a negative exponent, they're going to say, hey, can you write this answer with a positive exponent? Right? And all you have to do is take this number, put it in the denominator, and write it as a positive exponent. So we have like this, to write as a positive exponent, be 5 exponent 3 with a little 1 on top. Right? So the negative sort of just implies that it's on the wrong side of the fraction. Right? So right here, from the numerator, you can think of this as over 1. To make it a positive fraction, we flip it to the other side. Right? That's all it is. We flip it to the other side. Right? Okay. So let's practice this. Let's look at this one. I want to do two things. I want to write this as a positive exponent and evaluate. Right. So we look at this. Oh, it's a negative exponent. I'm going to flip it to the other side of the fraction. So this is has a little imaginary 1 there. I'm going to flip this. So the 1 goes on the top, and the 2 goes on the bottom, and its exponent 1 stays there. And now it's positive. That's it. Is that okay? Does that make sense? Okay, so now to evaluate, well, the top is a 1. We don't need to change that. We just do this calculation. What is 2 to the exponent 1? 2. So that just remains a 2. So those are the two answers. We have our positive exponent and we have our evaluation. Okay, the next one. How will this look like with a positive exponent? Sorry? No. As a power. Right? So this is over 1. We flip that fraction, okay? So this is going to be a 1 on the top, 3 on the bottom with a little 2 like that. Right? So if you give it a negative exponent, you just kind of flip it to the bottom of the fraction. Now, for the second part, Junior, we want to evaluate, right? What do we have on the top? What do we have on the bottom? 1 on the top and 9 on the bottom. Right, 3 to the exponent 2 is 3 times 3. That's 9. Okay. Okay. Final one. Now hopefully we're starting to get the gist of it. How do I write this as a positive exponent? Yes, thank you. 1, 4, 3. Like that. So that's just something to be aware of, right? They'll ask you to write it as a positive exponent. That's all we're asking you to do. If I want to evaluate that,
64 or
1 and 64. Thank you, Junior. And that's it. Okay, but this can get messy. So what happens, when we go back over here, is hey, you do the calculation, and the denominator has a negative exponent. And you want to write this as a positive exponent. We do the same thing you did before. We flip the fraction. So these goes from the bottom to the top. So that gets written as 4 to the exponent 2. Okay. We flip it to the other side. All right. And okay, so let's do this one. Oops, it's jumping. It's jumping. Where did it go? There we go. So once again, asked to do the thing. Positive exponent and evaluate. What would this one look like as a positive exponent? All right? Is this too much? Noah? Yeah. 5 to the exponent 2. Now, if you wanted to, you could put this over 1, but a 1 denominator does not need to be shown. Right? So we flip that fraction. We don't need to show that 1. And if you want to calculate it, what does that equal?
25.
Thank you. And that's it, right? How does this one look like as a positive exponent? Right? Noah again? 2 exponent 3. You take it from the bottom, you flip it to the other side. Right? Negative exponent, just flip it on the side of the fraction it is. And 2 to the exponent 3, we've done this a lot of times. What is that number? 8. Okay, and that is it.